wonder how your computer can juggle like a dozen different tasks at once without completely freaking out? Or how your printer just knows which document to print first? Well, the secret is this surprisingly simple but powerful idea, the digital waiting line. So let's pull back the curtain on this amazing structure that keeps our entire digital world from just falling apart. Yeah, really. What do they have in common? A lot more than you'd probably guess. You see, both of them rely on a basic rule of fairness to handle everything that gets thrown at them. It's the exact same principle that governs any line you've ever stood in. And in the computer world, we call it a queue. The golden rule for any queue is something called FIFO. It stands for first in, first out. And it's just beautifully simple, right? Whoever gets in line first gets served first. That's it. No cutting, no special favors. This one little principle is the absolute bedrock of how computers create order out of total chaos. Okay, so how do we actually build one of these lines inside a computer? Well, the most basic way is with a simple array. You can just picture it as a shelf with a fixed number of slots. To make it work, we just need to keep track of two spots, the front of the line and the rear, which is where new things join. So when a new task shows up, and the fancy term for this is Enqueue, it's just like someone joining the line. First, the system checks, hey, is there any room? If the answer is yes, the new item gets placed at the rear position, and that rear marker scoots back one spot to make way for the next one. Easy enough, right? And then when it's time to actually do something, that's called Dequeue. The system heads right to the front of the line, it grabs that first item, takes care of it, and then moves the front marker forward one spot. Next, it seems perfect, it seems foolproof. But hiding just under the surface of this simple system is a really big problem. So where does our perfect little line break down? Because it works great until all of a sudden it doesn't. There's this one specific scenario where the queue literally fools itself into thinking it's full when it isn't, and that leads to a huge waste of space. Okay, just imagine our line has, say, 5 slots, and it was totally full. Now we've just served the first 2 people in line. See that? The front pointer has moved up, which means there are now 2 perfectly good empty slots at the very beginning of our line. So, logically, we should be able to add a new person to the back of the line, shouldn't we? I mean, we've got empty space. The rear pointer might be at the very end, but those spots up front are completely free. It's just common sense. Nope. The system will actually throw an error. See, the rear pointer has hit the physical end of our shelf, and it has no idea how to use that empty space back at the beginning. It falsely reports that the queue is full. This is the false full problem. And this is the core of the problem. Think of that rear pointer like it's on a one-way street. Once it hits the wall at the end, it's stuck. All that empty space up at the front, totally wasted. It's unreachable until the whole line is empty. And in the world of computing, wasting memory like that is a huge no-no. But of course, computer scientists came up with a really brilliant solution. They asked, what if the line wasn't a straight line at all? What if it was a circle? And this is where we get the circular queue, which is a way more efficient design. And this just illustrates the idea perfectly. A circular queue basically connects the end of the line right back to the beginning. So when that rear pointer hits the very last spot, its next move is to just wrap around to the first spot, if it's free, of course. All of a sudden, no space is ever wasted. It's genius. Now, the magic that makes this whole wraparound trick work is a simple math operation called modulo. The best way to think about it is like a clock. When you go past 12, you don't go to 13, right? You wrap around back to 1. Well, modulo does the exact same thing for our queue. It tells the rear pointer that after the last spot comes the first spot, letting it loop around again and again. So when you put them side by side, it's really a no-brainer. The old linear queue, it wastes memory and it gets stuck with that false full problem. The circular queue, on the other hand, is super efficient, it has no major flaws, and it uses every bit of space it's given. It's such a simple change in thinking that solves a massive problem. Okay, so we've pretty much mastered the basic waiting line. Now let's check out a few specialized versions. Because, not all tasks are created equal, and sometimes you need a queue that has some special powers. First up is the priority queue. And the best analogy for this is a hospital emergency room, right? Patients aren't treated in the order they walk in the door. They're treated based on how serious their injury is. A priority queue in a computer works the exact same way. High-priority tasks get to jump right to the front of the line, making sure the most critical jobs always get handled first. Then you've got this one, the double-ended queue, or Dequeue for short. This is like the super flexible cousin in the family. It completely breaks the FIFO rule by letting you add or remove things from either the front or the back. It's like a line where people can join or leave from both ends, which is really useful for some of the more complex problems out there. So after all this, why does it even matter? Because once you get this concept of a queue, you start seeing it absolutely everywhere. It is truly one of the fundamental organizing principles of our entire digital world. I mean it, your computer's processor is using a queue right now to figure out what to do next. When you send a bunch of documents to a printer, they line up in a queue. Every single bit of data sent over the internet is managed in queues. Even your keyboard has a tiny little queue, a buffer, to remember the keys you typed while the computer was busy. They are the invisible, unsung heroes of efficiency. And it all comes back to that one simple, elegant rule of fairness: first in, first out. This single idea applied in all these clever ways is what prevents digital gridlock. It's what makes sure that everything gets handled in an orderly, predictable, and efficient way. So the next time you're streaming a video, sending an email, or even just typing a sentence, take a second to think about all those invisible lines forming and dissolving behind the scenes. Now that you know what to look for, where else can you spot a hidden queue working to keep your world running smoothly?